For designing the K-map for task 1, I used a guide similar to this for creating the truth table, and for 00, the output should be this, where only the G is low, so I made G as 0 and all other outputs as 1, and I followed this image for all the truth tables. And for K-mapping, I use this technique M0 to M9 to plot the digit either 1 or 0 for the K-map, and if the output is or doesn't belong to any of these digits, I labeled it as X or don't care. And using K-map, I arrived with this Boolean expression, where this expression is applied if A is the most significant bit, and the opposite of this is applied if A is the least significant bit. And for simulating the logic circuit, I use the second expression, where A is the least significant bit, and I repeat the process. Instead of output A, I inspected output B, and again using the K-map and using the expression for least significant bit. For the hexadecimal, I used a guide again for creating the truth tables, and using this M0 to M15 to make the K-map, and the process is a bit longer compared to the BCD, so I didn't label the groupings for the K-map. This is my task 1 using logically, and I have created several integrated circuit for each output A, B, C, D, E, F, and G. And for A, I followed the Boolean expression from the K mapping. This is A, and this is for B, this is for C, for D, E, F, and G. All of these circuits in each IC are followed from the K-mapping presentation. And let's start testing this when our LSB is A and MSB is D. And let's start in order. A is 1, that is 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is my simulation for task 2, the hex to 7 segment display in Logic D. The same with task 1, I created different IC for each output, and these are followed from the Boolean expression from the K-mapping of hex to 7 segment display. I have the input A for the LSB and input B for the MSB. And let's start simulating from 0 until the last output, which is F, that is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, A, A, B, B, C, C, D, D, E, E, and lastly F, F. This is the prototype using Tinkercad of BCD to 7 hex segment using different logic gates such as OR gate and NAND gate and an inverter, and also 4 slide switch that symbolize A, B, C, and D. And if we test by simulating in 0, 0, 0, 0 inputs, the output in this display is 0, and if A or the least significant bit is high, it will display 1. The same with if B is high, will display 2, and it is 0, 0, 1, 1, that is 3, and if C is high, that is 4, 5, 6, 7, and D is high, 8, 9, and that is the limit for the BCD to hex segment until digit number 9. The circuit on the left side is the circuit or prototype using CD4511, and I am going to compare with my task 3 circuit and task 4 circuit. With 4 inputs at low on both circuits, the output for the segment is 0. Same with 1, and also with 2 and 3 and 4 and 5, 6. The 6 in the left side or using CD4511, the A is low while on the right side the A is high, but they both represent the number 6. And the next is 7 and then 8 and 9. And again, they also differ in the last in D output, where the left circuit is has a low D output, and on the right side it has a high D output. And that is the difference between the two prototypes in Tinkercad.